We're going to go over what unit vectors are in this video and how we use them. And we should recognize this name, unit vectors. We have something else that we have covered this year related to unit. Remember, in math, unit means one, right? So unit vectors are vectors. A unit vector is a vector with a magnitude of 1. Can be in any direction, but its magnitude has to equal 1. Now, remember, if we were to talk about a vector, we tend to write vectors either in bold or with an arrow. And so if we're talking about a vector that has a magnitude of 1, the way that we note that is with the double bars. That means magnitude. So the magnitude of vector v equals 1 if vector v is a unit vector. So if vector v is a unit vector, that would mean that vector v's magnitude has to equal 1. And remember, the formula for magnitude, if we have a vector v, the magnitude of vector v is calculated by doing the square root of its x component squared plus its y component squared, right? So if we had vector v and we had defined vector v as in component form as vx comma vy, well, then the magnitude is found using the Pythagorean theorem of the legs, which you have seen in earlier parts of the lesson. And then if the magnitude comes out to be 1, then v is a unit vector. Now there are some very special unit vectors that we have to talk about, and they are called the standard unit vectors. So the standard unit vectors, they get some special notation. So in 2 dimensions, we only talk about 2 of them. In later math, you might talk about 3 different ones in 3 dimensions. But we talk about the standard unit vectors are the I vector, so I, and that's the unit vector in the direction of the x-axis. So it's going to have a length of 1 in the x direction and 0 in the y direction. And because it's a unit vector, we tend to give unit vectors this little hat notation instead of the vector notation. Okay? And so vector I would be this vector here. It's the unit vector in the x direction, and we would call that I hat. And I can probably zoom in a little bit so you can see that better. The other standard unit vector is the j hat vector. So j. And it's going to be in the y direction, so it's not going to have any x component, and it's going to have 1 in the y direction. And so if we were to draw the j vector, it's going to be on the y-axis, and it would look like that, the green vector there. So let's do a quick check to see if we understand how to tell if a vector is a unit vector. So let's say that I have vector A has, in component form, is 3, 2. Is vector A a unit vector? Well, let's sketch vector A, right? So vector A, I always like to sketch my vectors, so it's going to be 3 in to the right and 2 up. And I think you can tell by Pythagorean theorem that if it has a leg of 3 this way and a leg of 2 this way, there's no way that the length of this hypotenuse is 1. But let's check it out. The magnitude of vector A is equal to the square root of 3 squared plus 2 squared. So that's the square root of 13. So the magnitude of vector A is not equal to 1. So vector A is not a unit vector. That's all you need to do to prove something is a unit vector, is to see if its magnitude is 1. So why are these useful? So we have another way that we can write vectors. We know that we already have learned that we can write vectors in their component form, right? So this vector here, 3, 2, in its component form, right? Well, we could write that vector. So let me just redraw this 3, 2 vector. I'm not going to draw it yet. I'm going to draw some I vectors. So I'm going to draw my I vector. There's my first one. There's my I hat. Plus another I vector. There's another I hat. Plus another I vector. There's another I hat. So we know from scalar multiplication that when I take 3 I hat vectors in the same direction, I could say that that's equal to 3 of those little I vectors. And then I could do 2 j vectors from there. And these are 2 little j vectors. And I would end up at the point of the tip of my 3, 2 vector. So this vector, A, which is equal to 3, 2 in component form, we can also write that as a sum of 3 I vectors plus 2 j vectors. And that's called the linear combination of unit vectors. That's that form. And it really is no different than just taking the x component and multiplying the x component by the I vector, and then the y component and multiplying it by the j vector. Now, there's something very important about unit vectors and their relationship with the unit circle. So let's just go back and think about the unit circle for a minute here. We know that the unit circle is the circle that has a radius of 1. So I'm just going to try to draw a circle with a radius. It's not going to come out too great. Okay, but there's my circle. And we know that every point on this circle is 1 distance away from the center. So if I was to take this point right here, that's the point 1, 0. And if I was to take this point right here, that's the point 0, 1. And what you should see here is if I was to draw my radius in but put an arrow on it, that's that I vector. And if I was to draw this radius in and put its arrow on as a vector, that's the j vector. And it turns out that on the unit circle, since the radius to any point on the unit circle is 1, all of the points on our unit circle define the tip of a vector in standard position of a unit vector. So for example, if we were to take our 45-degree point, we have root 2 over 2 and root 2 over 2. And if we were to look at that and say, let's call this, let's take this as our vector. Let's say we have a vector, and we'll call it little a, and it has root 2 over 2, comma root 2 over 2 as its component form. Is vector A, is it a unit vector? Well, we can check. We think it should be because its radius comes from the unit circle. And so, well, how would we check? Well, we would do the square root of root 2 over 2 squared plus root 2 over 2 squared. And we would get the square root of 2 over 4 plus 2 over 4, which is equal to 1. That's the magnitude of A. And so, yes, A is a unit vector. And so any point on our unit circle, we could pick this point over here and say for 120 degrees, we know that we had minus root 3 over 2, not 120, I'm sorry, for 210 degrees, minus root 3 over 2 and minus 1/2. And that radius was also 1, and so that's also a unit vector. So any point on our unit circle, all the special ones we memorized, and any other point, all of those points would define a vector that has a magnitude of 1 coming from standard position, placed in standard position. Now, if we remember one step more, on the unit circle, we can just sort of remember back to when we did our unit circle. We knew that these numbers were more important than just their placement on the unit circle. When we memorized these numbers, they came from us drawing all of these special right triangles in here. So remember, we had made the unit circle by drawing a 30 degree, a 30, 60, 90 triangle. And we said if the hypotenuse is 1, then the opposite side would be 1/2, and the adjacent side would be √3/2, and that's what gave us this x and y coordinate. But it was more important because if I said the sine of 30 degrees is the opposite, 1/2, over the radius, 1, it turns out that all of these points on our unit circle are, in fact, the cosine of our angle and the sine of our angle. So this is just review. Every point on our unit circle, the x value is the cosine and the y value is the sine. And so if we start to talk about unit vectors and their relationship with the unit circle, what we find is that all of the points on the unit circle define unit vectors. So every xy combination defines a unit vector. And not only that, we can determine, or it will identify, the angle of our unit vector because we know that these points are the cosine and the angle. So we can find the angle of our unit vector from the fact that the cosine of the angle is going to equal the x component and the sine of the angle is going to equal the y component. And we'll get into that a little bit more, but it's important that you understand that the unit vector has a very important relationship to the unit circle.